Okay, so that last video was from last year during quarantine when we were kind of all stuck at home and I had my kid with me. So sorry about that. I just hate to make a whole new video because my son was screaming. So this is the second part of the notes. It says, if there are m ways that one event can occur and n ways that another event can occur, then there are m times n ways. So what we had said before, we didn't have to make a tree diagram now. We just can multiply all of our ways together. So for example, in example 3, it says Ryan's getting ready in the morning and he wants to look super fly for math class. He has 3 pairs of sneakers to choose from, 4 types of pants, 8 shirts, and 3 chains. So we're not going to sit here and go, we could go to these 3 sneakers and from those 3 sneakers to 4 types of pants. We don't need to do this tree diagram anymore. We can use the fundamental counting principle, which just says multiply all your ways together. So what's 12 times 24? It's going to be 288. So there's 288 ways or outfits. Okay. How many possible combinations are there for a 3 combination lock? So when you're at your locker, it's the number 0 through 39, which is equal to 40 digits because we're counting 0. Okay, so you turn your locker to the right, you turn it to the left, and then you turn to the right. So I have 40 digits to choose from. We're allowed to repeat numbers. It didn't say we couldn't. So you have 40 options for your next number and 40 options for your next. If I multiply those ways together because I'm doing something and then I'm doing something and then I'm doing something, then I have 64,000 ways or combinations. Okay. How many ways versus what is the probability? So how many ways is just a number, like 64,000 or 288. When we say probability, we're asking for a fraction, something out of something. So here, if there's 0 to 9 digits randomly, that means that there's 10 digits total. Okay. We're saying find the probability that the first number selected is a 5 or 7. That's 2 numbers out of 10. The second number is a 2, and that's 1 number out of 10. And the third number is a 3 or 9. That's 2 numbers out of 10. So those are probabilities. So if we use the fundamental counting principle with probabilities, we're going to have fractions. We're going to say a fifth times a tenth times a fifth. And you're going to get 1 out of 250, or I want you to get in the habit of writing it as a fraction or a percent. Okay. Okay, so that's it for your first day of notes. Now this is checking for understanding or homework. You're going to fill out these notes and submit both sheets. So this is the work instead of doing Delta Math. It says, what is the probability of a spinner and it lands on an odd number? Well, there's 8 numbers here, so it's always out of what you have. Odd is 1, 2, 3, 4. So the probability of getting an odd is 1/2 or 0.5. If you're starting to do this in copy, and you're copying currently, I want you to pause the video. I want you to try it on your own and see what you learned. Then come back to the video, okay? Number 2 says, what is the probability that the sum of the numbers on the 2 cubes is a 6? So let's think about that. You could have gotten a 1 and a 5, a 2 and a 4, a 3 and a 3, a 4 and a 2, or a 5 and a 1. That's 5 out of, what were all our possibilities in our notes? There was 36. So it could be 5 out of 36 or 0.14. Okay, there are 9 green marbles, 5 red marbles, 3 blue marbles, and 1 yellow marble. Abby pulls one out of the bag. Devin bets she will get a green marble, and Allie bets she will get not a green marble. Who would you go with? Allie's or Devin's guess? So there's theoretical probability, which Devin said she's going to get a green marble. Well, there's 9 green marbles, so let's say Devin's probability. Devin says that she's going to get a green, which is 9 green marbles out of, let's see, 9 plus 5 plus 1 or 9 plus 3 plus 1. So that's out of 18. So she guesses she's going to get a green, which is half the bag. And then Allie says the probability she's not going to get a green. So what's called the complement? Little c, the complement of green is not being green. So what is the opposite of 9/18? It'd be 9/18. So not getting a green would be 1, 2, 3, 4, 5 red, 1, 2, 3 blue, and 1 yellow, which is 9. So it says, who would you go with, Allie's or Devin's? It wouldn't matter. Both same probabilities. Now, these are theoretical, okay? These are theoretical. You might end up with a yellow, which will also be not green. Just because it has a higher probability doesn't mean you'll necessarily get it. It says Josh is having a contest. He's put on the first floor 3 gift certificates to Best Buy. And on the second floor, there are 5 rooms with a gift certificate to Best Buy. You are only allowed to pick one room. There are also 30 rooms on the first floor and 35 rooms on the second. Which floor would you choose to find the gift certificate? So if we have floor 1 versus floor 2, which one would you go with? Which floor to pick a room? All right. Well, on the first floor, there are 30 rooms. On the second floor, there are 35 rooms. There's 3 gift certificates on the first floor, and there's 5 on the second. So this is 1 out of 10 rooms, and this is 1 out of 7. So 3 divided by 30, yeah, that's 10% versus 14.3%. So I would go with floor 2. Okay. What is the likelihood that you pull 2 quarters out of your pocket and they both are Florida quarters? One is an Ohio quarter and the other is a Kentucky. So I remember one time someone said to me, "Oh, I got two quarters in my pocket that are the same. What's the probability?" Well, a Florida quarter, there's 50 states, right? So that's 1 out of 50 and then 1 out of 50. Because it could be the same state again. So that's 1 out of 2500. So that is a very small chance, okay? And then it's so small in the calculator, it writes like this. It's pretty much so close to 0. Okay, and then here, same thing. Oklahoma would still be 1 out of 50 and Kentucky be 1 out of 50. It'd be the same thing, okay? So use a fundamental counting principle to determine how many possible codes there could be for a door. Below, if it's a 4-digit number. So if you're a robber or burglar and you came up to this door code, all right, and you're like, all right, I need to get in this door. I guarantee that there's a 4-digit code, and I see that this number, this number, this number, and this number are the ones that get used over and over and over. So those are 4 numbers to choose from. I could have picked 9, I could have picked 1, I could have picked 7, I could have picked 0. So I have 4 numbers to choose from. Say the first one's a 9. We use it. How many more do you have left to choose from? 3. Say it was 0. Then you have 2 to choose from, and then 1. So the fundamental counting principle says multiply your ways together if you're going right in a row. If you do something, and then you do something, you do something, and then you do something, you multiply all your ways together. So if you're standing at the back door and you're like 9071, that's not it. 9701, that's not it. 9710. How many different ways are there? There's 24 ways. Okay, submit this in your folder, those sheets, and you can start on day 2 if you wish.